Hello everyone, I am Dr. Sirajul. I welcome you in my YouTube channel. Today in this video, I am going to talk about active methylene compounds. So first I will introduce what is meaning of active methylene compound. Then I will talk about the preparations, then physical properties, then chemical properties. KETO-ENOL tautomerism is also very important. Stability of keto form, KETO-ENOL tautomerism in ethyl acetoacetate, synthetic uses, conclusions, reference, and knowledge. Acknowledgements. So, my friend, let us start active methylene compound. The class of compounds containing a methylene CH2 groups directly bonded to 2 electron withdrawing groups are called active methylene compounds. Ethyl acetoacetate and diethyl malonate falls in this class. Now we shall discuss about preparations, properties and uses of ethyl acetoacetate. The structure of ethyl acetoacetate is CH3COCH2COO-C2H5. Now preparation, collision condensations. Two molecules, ethyl acetate, undergo reaction with sodium ethoxide and form this compound which is known as ethyl acetoacetate. Let us discuss the mechanism of these reactions. You can see in step 1, ethoxide taken these hydrogens and formations of ester anion. And then ester anion attack on carbon and forming this product, and oxygen have negative charge. Then step 3, you can see. So this is the ethyl acetoacetate. Now physical properties. Ethyl acetoacetate is a colorless, pleasant smelling liquid with boiling point 180 degrees Celsius and density 1.0282. It is sparingly soluble in water but freely soluble in organic solvent. Now friends, I will discuss about chemical properties. As the methylene hydrogen is acidic in nature, hence it can be easily replaced by some other groups. Hence, from ethyl acetoacetate, we can synthesize large number of compounds. Now, why the methylene hydrogen is acidic in nature? This is questions to be answered. So, acidity of methylene hydrogens. You can see the formation of carbon ion and giving H+, and this is in equilibrium. It is attributed to factors. Inductive effect. You can see here oxygen's partially negative charge, oxygen partially negative charge, carbon partially positive charge, carbon partially positive charge. So, this stable carbon ion is formed. Now resonance effect. You can see this anion is resonance stabilized. You can see resonance hybrid from one oxygen to another oxygen. Now friends, salt formations. A strong base, a strong acid, it gives enolate anion, weaker base, a weaker acid. Alkylations. We can see here this enolate anion and weak base attack and take this R and breaking off this RX bond. So monoalkylated acetic ester form. Hydrolysis. There are two types of hydrolysis. Ketonic hydrolysis. Ethyl acetate undergo hydrolysis acetoacetic acid, and you can see carbon dioxide will remove, decarboxylation occurs on heating, and acetone is formed. So formation of acetone from ethyl acetoacetate through ketonic hydrolysis. So acidic hydrolysis, it takes 2 molecules of water, and in the presence of conc, sodium hydroxide and dilute hydrochloric acid, it gives 2 molecules of acetic acid and 1 molecules of ethanol. Now friends, KETO-ENOL tautomerisms. Aldehyde ketones and some other compounds undergo these special types of tautomerism. It involves the migrations of a proton from alpha carbon to the carbonyl oxygens. Keto form, enol form. So stability of keto forms. Due to greater strength of pi bonds of CO group as compared to that of carbon-carbon double bond groups, the keto form is more stable than enol form. In simple aldehyde and ketone, the amount of enol form is negligible. However, the percentage of enol form increases in case of 1,3-dicarbonyl compounds. It is because of the formations of intramolecular hydrogen bonding. So, keto-enol tautomerism in ethyl acetoacetate. Ethyl acetoacetate exists as a tautomeric mixture of keto-enol and enol forms. You can see keto form 90% and enol form 10%. So facts in favor of keto form. Ethyl acetate form a bisulfite compound with sodium hydrogen sulfide. Ethyl acetoacetate forms a cyanohydrin with hydrogen cyanide. Ethyl acetoacetate forms anozymes with hydroxylamine and phenylhydrazone with phenylhydrazine. On reduction with sodium amalgam or by using lithium aluminum hydride in pyridine, ethyl acetate gives beta-hydroxybutyric acid containing a secondary alcohol groups. So you can see the beta-hydroxybutyric acid ester. When ethyl acetoacetate is hydrolyzed with dilute sodium hydroxide solution in cold followed by acidification, it forms acetoacetic acid. This on heating yield acetone, thereby showing that acetoacetic acid is a beta keto acid and ethyl acetoacetate is beta keto ester. You can see acetoacetic acid melting point 36 to 37 degrees Celsius and formations of acetone on heating, decarboxylation. So facts in favor of enol form. Ethyl acetate reacts with sodium metal to form sodium derivative and hydrogen gas is evolved. This indicates the presence of OH groups. Ethyl acetate forms an acetyl derivative with acetyl chloride which shows the presence of OH group. When ethyl acetate is treated with alcoholic bromine solution, the brown color of the latter is discharged, and this indicates the presence of double bonds. Ethyl acetate forms a reddish violet color when treated with ferric chloride. This indicates the presence of carbon-carbon double bond and hydroxyl group in structural unit as in phenols. So, synthetic uses of ethyl acetoacetate. Ethyl acetoacetate is used for the synthesis of various compounds such as mono and dicarboxylic acid, alpha-beta unsaturated acid, ketones, 4-methyl uracil, and antipyrines. So my friends, from the above conclusion, we can conclude that ethyl acetoacetate is ethyl ester of acetoacetic acid. It is used for synthesis of large number of compounds. It is also as a flavoring for foods. So these are the references. So if you like this video, then subscribe my channel, and thanks for watching.